Hi, my name is Zoltan, and today I want to show you the ZolarLoo, my newest invention. So what is the ZolarLoo? It is a mobile toilet that separates and dehydrates human feces and urine, and by that enables the safe and economic reuse of human waste as fertilizer. So you see it has a double roof. So the first roof is transparent plastic. In this case it's fiberglass, which transmits enough UV light of the sun that the urine that is pumped from below to the roof is hygienized. So all the bacteria that are in the urine are killed by the UV light, and this also enables the concentration of the urine without nitrogen loss, because usually the nitrogen in the urine is in form of urea, which is the same chemical that is also found in mineral fertilizer. But because it is in a liquid and water in the urine, there will be bacteria that produce an enzyme which is called urease, and then this enzyme converts the urea, which is more or less stable, into ammonia, which is a gas, and it's outgassing, and it produces the very bad smell of old urine, and you also lose the nitrogen that you want as a fertilizer. But if you expose it to constant or daily UV light, the bacteria are killed and you don't have this enzyme, and so you can stabilize the urine and concentrate it and only lose a small fraction of the nitrogen. So that's the main idea behind this toilet, because urine in itself is a very good fertilizer, but the big challenge is that it's mostly water. So if you want to transport it somewhere for application, you're mostly transporting water, which is quite expensive. So if you can concentrate it with a more or less low-tech and affordable technology, you can make it affordable to use as a fertilizer. And so I can show you the inside. So the basic idea is that it's a so-called UDTT, urine diverting dehydration toilet, which typically comes in a version where you have 2 volts. So basically it's 2 toilets in one, but you only use 1 toilet at a time. So if you come here in, this is the toilet seat. So the toilet can be used sitting, if you just open the lid, or if you remove it completely, you can go here and then squat. And then the design is that you have the hole here where the feces are coming into, and then this surface here, the pee goes, and it's a so-called pee trap, which uses a so-called tea kettle effect. So basically you can also use a normal funnel, but the funnel might clog easily with solids. So this design basically, it uses stainless steel sheet that is wrapped around, and because of the radius and the small slope, so the slow flow of the urine stays attached to this metal sheet, then goes basically under the cliff, and then is diverted to a pipe, and then this pipe is the urine is flowing here into, and then below this extra urinal for men there's a small buffer tank which has a small float switch or liquid sensor which detects when there is urine in it, and it will switch on a small DC pump and pumps through this tube here the urine to the roof. So this is the main feature, and then basically this setup, you have it twice. So if you close this one here, this one is currently not in use. You can see here, if you go here, for the feces, what I use is basically a 200-liter big bag, which is made out of polypropylene, 60 by 60 by 60 centimeters. So there goes the tissue and the feces, but all liquids, or like the urine, is diverted. And also if you are an anal, like a water anal cleaner, the anal cleaning water goes here. So if you have finished your business, you just sidestep, and then for anal cleaning you can use the water here, and then the water is diverted to the outside that I'll show you in a moment. And so the basic principle is that you use this toilet for, depending on family size, half a year to a year, and then when the bag is full, you stop using it, you close it up, and you move to the second toilet, and then use this one for half a year to a year, while the feces here are continue to dehydrate, to dry. And when the second one is full, these feces will be very, very dry. You can remove them and they will be basically like dry earth. And most of the pathogens will have died off with this dehydration process, like all the viruses and the bacteria. You have still some nasty like intestinal worms, hamlin, which can lay eggs, and these eggs, they can survive also the dehydration. So if you want to hygienize the feces for fertilizer use completely, you should either do a heat treatment afterwards, or, which I plan to do probably, is to make charcoal or biochar of it, because then the biochar you can mix with the concentrated urine from the roof and get a highly concentrated organic fertilizer out of it, and safe fertilizer. And then, so basically we have a 40-watt solar panel on the roof. Here is a charge controller. The solar battery is hidden behind the step. And so the solar is used once for the small urine pump. We have here also a small light for the night. And then also a very important feature is that we have here these vent pipes, and between each vent pipe we have a PC fan, 120 millimeter, that is constantly running. And so this first increases the dehydration rate for the feces, and also keeps this inner room very, very odor free, because like even when you're doing your business, any odor is immediately sucked up and to the roof. So it's even like you have less odor in this toilet than you have in a normal flush toilet, because in the flush toilet, when there are some feces still in the toilet, you have the odor in the room until you flush it, and then still you have the odor a couple of minutes in the room, in the toilet, while in this case basically you don't have any odor at any time, which is, it's really nice. And so we have rainwater being collected from the transparent roof, so it's not touching any of the urine. So the rainwater comes here with this 150 liter tank, and so you can wash your hand with soap below. And then we have the washing water for the hand washing, as well as for the anal cleaning. You see the exit here goes to this banana plant, which is grown quite nicely. So we have been using the toilet since a month now. So we bought it like when it had just one leaf. So now these two leaves have grown since a month ago. And so the basically design principle of this toilet is also that it's a mobile toilet. So the main reason for that is that it can be prefabricated at one place, and then if somebody's interested in getting the toilet, it is ready to ship and can be immediately be used once it has been shipped. Yeah, and so like the odor is very minimal. Like in the inside there is no odor at all. In the outside, depending on the wind conditions, you might have some odor from the drying urine, which is very distinct from the very, very bad smell you get from unstabilized urine that you, for instance, would have in the shade. But still, if you want to reduce the odor further, like if you're close to a house, like in this case, you can, or the plan is for me, is to add some charcoal odor filters, which basically is like a double wall all around the basin for the urine that you fill with charcoal dust that will absorb the odor, and then at the end you can use that charcoal to mix with the urine and have your biochar fertilizer. Yep. So I have slightly modified the urine separator, which uses the teapot design or teapot effect, where the urine is adhered to the surface, in this case of the stainless steel, and any solids will drop into the feces hole here. So what I did to improve the separation, and reduce the amount of liquid that is dropping into the feces hole, is that I first increase this bend radius so that the urine has it easier to stick to the surface, so it's not such an abrupt and sharp edge or bend here. That's the one point. Then also what happens if the urine touches the wall, it will stick to the wall and then drop into the feces hole instead of going below and then into this tube. So to prevent this, I have pulled the stainless steel foil up here so that the water is directed slightly away from this PP wall and then flows in the middle and doesn't touch so much the PP wall here. And then the final thing is probably not visible on the video, but I have slightly sanded the stainless steel just here on the edge in this direction, so in the flow direction, because I did a bit of research and saw that also like brush steel, or you can mimic it with in sanding it in this one direction, improves also the adhesion, basically increases the surface energy. So I can show you now. So it works quite well. So I'm quite happy with the improvement. It can be quite heavy before it starts tripping over. That's it. So my initial setup with the capacitive sensor did at the end not work so reliable, so somehow it didn't detect the liquid level consistently. So sometimes it detected it, sometimes it did not. So I switched to a mechanical float switch, a small one, but that one only can switch a maximum of 0.5 amp. So I also switched to a smaller pump, which is still powerful enough. So this is the urine buffer tank. So if you have some urine, in this case water for testing, is poured in. The switch will switch on the pump and it will drain the urine and only leave a few, like a centimeter or so. Try it again. And then the idea would be that at the end of the day you will flush the urinal with like small amount of water, so that the remaining urine is also pumped to the roof where it's evaporating. So this graph shows you the estimated share on total fertilizer value of urine and feces. So approximately 80% goes to the urine, and the remaining 20% fertilizer value is in form of the feces. And you see that the fresh urine and feces are mostly water. So 95% of the urine is white water, and 75% of the fresh feces is water. and the annually produced amount per person is 500 liters of urine and 55, depending on the diet, kilograms of fresh feces. And the high water content is actually a challenge for the economic reuse of human excreta as a fertilizer, because they mean higher transport and storage cost. So in this graph, you see the amount of fertilizer you need for the same fertilization effect. So it's normalized to mineral fertilizer at 1. So you see that for urine, if you would use fresh urine, you'd need like 33, 34 times the amount to transport to get the same effect. And for feces, which we should not use freshly because of the pathogen dangers, it's 15, 16 times the amount. But if you concentrate it through dehydration, what the ZolarLoo does, you can lower this difference compared to mineral fertilizer to around 3 to 4 for both urine and feces. So this makes a big difference in the total cost of using urine and feces as a fertilizer. Yeah, and this is a overview comparison between a ZolarLoo, a pit latrine, and a flush toilet in the case of a 4-person household in Kenya. So if you look at the water use, there's 0 water use in the ZolarLoo, like the ones you need for washing and cleaning can be covered by the rainwater that is collected from the roof. And this is in contrast to the flush toilet that uses around 150 liters a day, depending on the type of toilet. The cost is a bit in the middle ground with an estimated cost of 400 euros. So the pit latrine will be slightly cheaper typically, but the flush toilet, if you include all the costs, is typically higher. The hygiene is best because there is no flies because of the dehydration and the constant ventilation, and there's also no aerosol. So there's, like for instance, the flush toilet, when you're flushing, basically you have small water droplets that still have like the urine and the feces, which are distributed in the whole bath when you flush and settle on all the surfaces. And in a dry toilet like the ZolarLoo, you don't have this. From the user comfort, the big advantage is there's no smell because of the constant ventilation and the separation of urine and feces. There's no splashing, which you can have in a water toilet. You have minimal stains, but on the downside, the feces are not flushed away and they are not very deep, so they might be visible to the user. If you look at the pollution of the groundwater, the ZolarLoo has the advantage that it protects the groundwater, in contrast to the pit latrine or a typical flush toilet where that is not connected to a proper sewage treatment system. Another advantage of this variation of the ZolarLoo is that it's mobile. So this opens up the possibility of renting or rent-to-own business models. And of course, the main aim is that the ZolarLoo enables the safe and economic use of excreta, human excreta as fertilizer, which both the pit latrine and the flush toilet do not. And especially if you're looking at a country like Kenya, where fertilizer is underutilized and you can have big increase in agricultural yields with more fertilizer use. This is a big plus. And the monthly costs are also low, more or less 0. The cost for collecting the dried feces and the dehydrated urine can easily be covered by the income from the fertilizer sale. Yeah, and finally, the regions where ZolarLoo can in principle work. So it only can work in regions where throughout the year you have sufficient sunlight with a sufficiently high UV index that kills the bacteria in the urine. So this is approximately more or less 30 degrees north and south of the equator, like shown here. If you're north or south of that belt, you will not have sufficient sunlight to make the ZolarLoo work throughout the year. Yeah, that's it.